guys, welcome to Algebra Maths. Okay, today I want to be teaching on logarithm. We have two types of logarithm. We have the common logarithms is natural logarithms. Okay, either you call it common logarithm or natural logarithm. Then we have the second one, which we call exponential logarithm. Okay, another word for this exponential logarithm, we call it theory of logarithms, or we can call it theory of logarithms. So we have two types of logarithm: exponential logarithm, also called theory of logarithm. Okay, now the common or natural logarithm is a type of logarithm that we use logarithm table, popularly called four-figure table, to solve. So in common logarithm, we use four-figure table to solve, to find a value. Okay, now for exponential logarithm, also called the theory of logarithm, in this type of logarithm, we don't use logarithm table, popularly called four-figure table. We don't use four-figure table here. All right, so today I'll be treating this exponential or logarithm, also called theory of logarithm, because students usually have problem with this topic. You usually find questions from this topic in SSC past questions. All right, today I'll be treating exponential logarithm. Let's go. All right, to understand this theory of logarithm, there are basically two things you need to understand. Two things, okay? If you know these two things, there's no question in theory of logarithm that you cannot solve. What are the two things? Number one, you need to understand the relationship that exists between indices and logarithm. There's a relationship that exists between indices and logarithm. So you need to know the relationship that exists between indices and logarithm. That's the first thing. Then the second thing, the laws of logarithm. So once you know these two things, there's basically no question in theory of logarithm that you cannot solve. So let me treat the first one, the relationship that exists between indices and logarithm. Now, if I have log A base B equals to C, now the way we read this is log. This log is abbreviation for logarithm. Okay, so log A base B equals to C. This A is the number, this B is the base. So if I'm to read log of A to the base of B is equals to C. Now this expression is in logarithm form. Okay, it's in logarithm form. Why? Because you are seeing log here, so it's in logarithm form. Now if I want to write this in index form, I'm going to have, I'll write A equals to this B, we raise this up, B raised to power C. Now this is in index form. All right, so this is logarithm form, this is index form. This is the relationship that exists between logarithm and indices. If you see this logarithm form, if you see this index form. All right, now let me use numbers to represent this. Imagine you have something like this: log 8 base 2 equals to 3. Now this is in logarithm form. Now if I want to change this to index form, I'm going to have 8 equals to this 2, we raise this up, 2 raised to power 3. Now observe, this and this, they are the same thing. They are the same thing. The difference is they exist in different form, but they are the same. This logarithm form, this index form. Okay, so that's the first thing you need to know. the relationship that exists between logarithm and indices. If I have this is the same as this, and if I have this is the same as this, they are both the same. Alright, so that's the first. Then the second one is the laws of logarithm. The laws of logarithm. Okay, now let's take the laws of logarithm. The first one was the relationship that exists between indices and logarithm. Now the second one is the laws of logarithm. If you know the first one, then this law, there's practically no question in indices, in logarithm, that you cannot solve. Let's go. What are the laws of logarithm? Number one, I have log a base b plus log c base b equals to log a number one. If I have log a base b plus log c base b, okay, this will give me log a times c base b. Now look at the first law. The log of a number to a certain base plus the log of any other number to that same base, if the base are the same, I will pick one. Then I will multiply these two numbers, a times c. That's what the first law is saying. The log of a to the base of b plus the log of c to the base of b, the base are the same, I will pick one, then I will multiply these two. That's a times c. Now, don't forget, a is symbolic. It means it can represent any number or any letter. The same with b. So what this law is trying to make you understand is if the base here and the base here are the same, that's the first thing you need to know. Then the second thing is addition sign is what is separated them. You can pick one of the base, then you multiply these two numbers. E.g., imagine I have log 3 base 5 plus log 2 base 5. The base are the same. I will pick one, that's log 5. Then I will multiply this, that's 3 times 2. My plus will turn to times. So I will have log 6 base 5. I will have log 6 base 5. So that's the first law. The base are the same. You pick one, then you multiply the two. Okay. Now the second law. The second law. The second law. If I have log a base b minus log c base b. Okay. Now the second law is like the first law. If the base are the same, then subtraction sign is what is separated them. The law says you pick one, I'll pick one of the b, then this I will divide a over c. Alright. If the base are the same, I will pick one, then my a minus will turn to divide, then c. So for instance, okay, I have log 6 base 5 minus log 3 base 5. Okay, the base are the same. I will pick one. That is log base 5, then 6 minus will turn to divide, then 3. Of course, 3 can go here. Into here, I have 2. So I'm going to have log 2 base 5. Alright, so this is the second law. If the base are the same, I will pick one, which is log base b. Okay, then I will divide the two. Why? Because subtraction sign will turn to divide. If it was plus, it will turn to times. Don't forget, these laws are vice versa. Meaning, if I have this, I can turn this to this. In the same way, if I have this, I can turn this to this. So the laws are vice versa. Okay. Now the third law. Okay. The third law. Okay. Number 3 law. log A raised to power C base B. Okay. Now look at the third law. If I have this expression, the log of A to a certain power, then to the base of B, what I will do here is this. This will come to the back of the log. That's C log A base B. That's what the law is saying. The log of A to a certain power to the base of B, I will move this here. Alright, take for instance, I have log 2 raised to power 5 base 4. Log 2 raised to power 5 base 4. Okay. What I will do here is this. This will come here, which is 5 log 2 base 4. That's what the law is saying. Okay, that's what the law is saying. If I have the log of A to a certain power, then the base, okay, I will move this power here, which is this, then the log of A base B will remain. All right, then the last law, which is the fourth law. The fourth law. The fourth law, so I have log B base B. Okay, now look at the first law. The log of a number to the base of that same number, mathematically, this is 1. All right, so the log of a number to the base of that same number is 1. If I have log 3 base 3, I will have 1. If I have log 5 base 5, I will have 1. So if the number here and the number here are the same, I don't need to solve. My answer is just 1. That's all. Alright, so with these 4 laws I've given you, in addition with the relationship that exists between indices and logarithm, you will discover that there's practically no question in theory of logarithm that you cannot solve. Alright, so let's apply these laws, this knowledge in solving some question. Let's go.